Good morning, this is Hallicrafters Rehabs. Welcome back. I hope you're having a good Easter weekend. This is Saturday morning, and I'm not one that's been very big on caveats and working with high voltage equipment, but I think this will take care of that for sure. Up to now it's all been play. But now we're getting into the serious. Everything inside of here is high voltage. And I've set this up to begin testing. I think I found all the mistakes I made that I'm going to find, but I did not find the mistakes that I'm not going to find. So that's why you have a rigorous testing program. Also for safety, you have a rigorous testing program. And there's high voltage everywhere in here. For example, here are the two B plus AC leads from the transformer. Each one of those has 300 volts on it. And if you grabbed this one and this one, if you were really stupid, you would be grabbing 600 volts, and the current is about 2/3 of the draw of the whole radio set, which would be around a 1/2 amp, which would be probably the last thing you did. So it's unlikely people are going to have their hands around here, but this in the rectifier area is really a high voltage area. The B plus, all of this in here, on average, 300 volts and the same amount of amperage. So it's quite lethal. Plus these things store electricity as well. But an underrated part of the set and its lethality is right here. This part. You know, your wife plugs in the hairdryer, but these days in the modern homes they have those current protection devices in the wall. There isn't one here. I do, in the working of this, I have well, let's get this on. I have a variac, and I'll be measuring the current as well. A dim volt tester, which is behind all that mess over here, and a isolation transformer. And the point behind that is to sort of limit the damage, if you will. For one thing, when you start things up on a variac, you're making sure you don't have any real shorts in the system, and you have to assume nothing. But in here, this is AC, and when it's plugged in the wall, it's got limitless, as far as us humans are concerned, amount of energy available to cause harm. So we have safety caps in here. They remove noise from the line, but they also fail open, so that there can be no hot chassis as a result of these cap failures. But the other thing is that part of the assume nothing testing, and I don't know if this is in camera shot or not. No, it's not. Bring this down a little bit. Is we're going to actually test the AC line here. Switch on and switch off. The first thing is switch off. There should be a ground, yes, but not the hot or the line should be grounded, and that's right. Then I have the inrush current limiter bypassed for my first test, so that's what this clip is in here. So with the switch on, nothing on the neutral. Well, here we go. Switch is on. Oh, this is on the wrong thing. It needs to be on ohms. Okay. There we go. I haven't used this meter in a while. It's going on the wrong setting. There we are. So, on the hot side, we see 23 meg ohms, okay? But that doesn't make sense. Come on. So just one. There. We're going to have to do like this. So I'm using this. Okay, here's the fuse. You get it. Bring the fuse on. Yes, fine. From fuse to switch. Okay, no rework necessary, just mass confusion on my part. Knowing which one is neutral and which one is the live, is you need to look at an actual plug. This side is neutral, this side is neutral, and that side is hot. So, to test the hot, we should be going through here, okay, 2 ohms, all right. It should go through the power transformer, 6.7 ohms, it does, okay. And that's, so from neutral, 6.5 ohms. Okay, no rework necessary. Okay, infinite with the switch off, 6.5 ohms, all right. I had, oh, by the way, I had the fuse out while I was doing half of that testing, okay. Yet, no connection to ground. No connection to ground. So that's the only test that needed to be done, really, was to make sure electricity went through the transformer and then back out to the neutral when the switch is on. And then when it's off, there is no, this is the live, and no part is the set except right here at the fuse is live. And it's live right here, live all the way to the switch. So you got AC power right here. Okay. All right. I could stand to tighten that power switch. Let me take a moment and do that. Okay, we're set to power up now. I have the isolation transformer on, ready to start up the other things. Prerequisite is to pull the rectifier tube because we're going to test the filament system for the tubes. I have a dummy load. It's actually an old Hallicrafters speaker, but I was reconing it and using dollar store super glue on the spider, and a big blob went on there. So it distorts badly, but it will still tell us that there's a speaker. So we've got everything off here. It's in the receive position. It's in normal IF. Okay. And we've done the measuring of the DC resistance and the inductance and everything. Okay. Set to on. It's on. The variac should be at 0. It wasn't. Okay. And sensitivity maximum. Okay. All right. Switch on power to power strip. So on. But we have no, all right. And we'll bring it to 30 volts. Slowly. Okay. I'm seeing current. That's wattage. I want current. 90 milliamps. We have 1.9 volts DC on this little rectified filament thing. I'm saying, this is saying 15 was barely enough. This should not be on DC. Oh, we're not going to get any. This, I could turn this one off because we have the rectifier tube pulled. Okay. That is not enough. Oh, I see a little glow in the light bulbs. In both light bulbs. Yes! Okay. So it says hold it for 5 minutes, but I think I will. This is a test procedure I put together so that I remember not to do, so I remember the order of things. So I'll come back after 5 minutes. I think I forgot to turn on the camera. What I've been doing is I moved it up to 60 volts, and I'm taking readings now. And like I say, you assume nothing. That's how you find the mistakes that you can't find. 3.5. I'm allowed to forget to turn on the record. 6K6 right here. 3.5. H6 will be less. Now, who's beeping at me? Comes in front of this resistor. Impossible to find. .3. There's a resistor that knocks down the voltage, and then of course we don't have anything, but we can measure on AC. These two leads. 174, 173. Okay, so that's telling me we're going to have B+. So that was a success. All right. Things. All right. So now we're close enough to 5 minutes at 60 volts. We're going to move it up to 90. Right now we're at 119 milliamps. I think this is really not telling me what I need to see. I'll just turn that off. This is an old one, and I'm pretty suspicious. We're fine on that. Right now we're at 95 volts, 161 milliamps, bright on the lamps, and let's go down and do our readings. So V1, oh, it's on the wrong scale. 5.4. V2. 5.4. V3. 5.4. V4. 5.4. V5. Back in here. 5.4. When I wired this thing in, I wanted to make sure I could get my probes in very easily without running into other connections and stuff. And it's paying off right now. 5.4 in the speed it takes to get these in. For this one, 3.9. It's got a resistor in line. It lowers 6H6s want lower heaters. Okay, so now we're going to go up to the primaries on the transformers. So, I mean secondary AC, which is 267. And did I do that backwards? 267. They're both 267. Okay. We have bright lights and everything. So we have a glow, a little bit of a glow on the 6K6, which is what we're supposed to show. And we're cleared to go to 120. All right. And we're getting 228 milliamps, which is about right for just the filaments. And so, we can turn this off. So let's start our round again. Ooh. Change the range down again. 7.24, which is a zero load. Okay, all right. Because we're not doing anything but running the heaters. This is not a great idea to keep it this way for a long period of time because you can burn out your cathodes. 7.23, yeah. People talked about just keep the heaters on, and if you have instant on, well, yeah, until your tubes are gone. So this will be the only time this radio has this condition. 7.23. Okay. Got the wrong one up here. Okay. Here. 7.23. I'm seeing glow in the 6K6. 7.27. And now for the 6H6. 5.4. And then we'll change our scale up here and check out the 355, 355. All right. Okay, and we have a current of 229 milliamps. Okay. All right, switch off. And we'll come back with the rectifier installed. Okay, the tube's installed. And now we're going to need to measure B+. So let me get this out. All right, we're ready to test B+. And power's on. And we're going to move it up to 30. Just sort of. So now we're testing B+. Should be nothing going on really at 30 hardly. Now we're beginning to see something. 380 milliamps. 2 whole volts. It's not even heated up the rectifier yet. see. I'm down at 2 volts, yeah.
2 volts, yeah.
200 volt
200
range.
volt range.
Charging up capacitors and stuff
Capacitors and stuff.
for the first time.
For the first time.
Rectifier and tube seems pretty cold, actually.
Pretty cold, actually.
See what my voltage is.
See what my voltage is.
30 volts.
30 volts.
It's 120 at milliamps.
It's 120 milliamps right
now.
Hmm.
And rectifier tube feels pretty cold.
Feels pretty cold.
That's when we give it a little more
Happens when
juice.
we give it a little more juice.
Okay, that was enough.
Okay, that
30 was
enough.
just not enough.
30 was just not enough.
All right, I'm going to switch this off a
All
second.
right, I'm going to
Wait a
switch
minute.
this off a second
And move that back to where it was supposed to be.
and move that back to where it was supposed to be.
20 volts.
20 volts.
Not a whole lot of
Not a whole lot
activity there.
of activity there.
All right, this back here.
All right.
Could be I just didn't have a good connection up here. All right, we're getting some voltage at, I have no idea what this voltage is here. 56. Bring it up to 60. $23 volts. Let it sit there for a while. Okay, it's stabilized at 18 and a half. So
Stabilized at 18 and a half, so that's,
there's almost nothing to record at
there's
this.
almost nothing
at
to
this
record
level,
at
so
this-
Let's bring it up to 90.
Let's bring it up to 90.
We're now up to 163, so we
We're now
are
up to 163.
actually
so we are
getting things energized.
actually getting things energized now.
So I'm just going to say not measured at 60
I'm just gonna
for
say not
everything.
measured at 60 for everything.
374 milliamps,
374 milliamps,
90 volts.
90 volts.
I don't expect any kind of signal.
I
Set
don't
this
expect any
based
kind
on
of
the
signal.
fact that
Set this based on the fact that
we have no idea where any of these
have no idea.
I
where
have,
any
sir.
of these
oscillator
have,
coils
sir.
or anything are at. So
oscillator coils or anything are at. So
a little scratchiness would be about the best
a
we
little
can get.
scratchiness
for
would be
today.
about the best we can get for today.
So it's stabilized at 170.
So it's stabilized at 170.
Okay. So now we're going to have to take measurements.
So now we're going to have to take measurements.
We get the other probe.
We get the other probe.
those other two voltmeters are really
Those other two
kind of sad.
voltmeters are really kind of
Overused
sad.
and worn out or something.
Overused
So in
and
V1,
worn out or something.
we're gonna look at,
So in V1, we're
I'm
gonna
gonna
look
actually
at.
I'm gonna do V1 and then do the rest
I'm
off
actually
camera.
I'm gonna do V1 and then do the rest off camera.
So at pin 6, this is right here. .92 volts. Probably appropriate for that level of 90 volts. And then for pin 8, .61 seems low. So it's 60 all the way around. That's pretty low. There's probably an anomaly there. So I'm going to do the rest of these off camera, and then we're going to have to think about this. Okay, well, I've gone through all of the tubes in basically low B plus everywhere, and consistently low. All the values about less than half of what they should be. There is a common mode associated with that, the rectifier tube. So let's see if we can find another rectifier tube and see what happens. So we'll turn this off and go get a rectifier. My tube tester's doesn't get everything. It's one of the cheaper ones that they made back in the day. But here I am at 30 volts on the input AC and 75 volts on the B plus. So there you have it. Tested the same, exactly the same, 28 and 30, or maybe it was 32 and 28 on that tester. So it's, it is what it is. So now we have something we can measure. So we'll go through and I'll do a 30 volt, or actually I've got to go up to 60. And the B plus right now at 60 is 200 volts. That was a tired. That's sad. That's probably, who knows why. Okay, I'm going to take measurements at 60 and 90 offline, and then we'll continue. Okay, so now it's time to bring it up to 120, where the rubber hits the road. No smoke yet, and the numbers were consistent. That's at 120. .330. Okay, so let's go back. We'll do the first tube and then do the rest offline. V1, this is 6, not the other one. 108, that's a good screen voltage. Not what it should be though. There's still an anomaly here. 176, also too low. 224. So the voltages are low here. We'll do one more tube. 187. It's right on the button. 104. Probably appropriate for being high. Okay, we'll do the rest offline. Well, it looks like I suffered from yet another tired 5Y3. Right there. I was down to my last 5Y3, and it's this Russian made, and it's tended to have high voltages for everything. But I put it in and everything went nominal. It's a brand new tube. Well, it's, I should say it's a tube that I haven't used before. I was a little scared of it because it seemed to be too strong, but it's right, just right for this set. So I'm going to redo all these voltages with this rectifier. It looks like it's going to work. So I'll come back after that. Okay, I'm at 90 volts, and there is an anomaly. I'm seeing 173 on the screen and 95 here. It's almost like these two are reversed. Or is it me? I'm reversed. How about that? I'm backwards. 8 is over here, 6 is there. 126, 99. Well, that makes all the sense in the world. 95, 173. So that should be, this is pin 8. The anomaly is in my head, okay? So there should be a difference in voltage. There is, 140, 172. Yay! So down here is 172, and there's 140. I am glad I got that right. Okay, we'll go back and we'll continue. So I'm going to stop here and separate out this video from the next. All of the B plus and the screen voltages checked out fine. So we have around each tube reliably a DC voltage envelope that turns the tubes on. And it took this third rectifier for that to be done properly. And but the radio basically was a deaf mute, and it was not getting any signal, and it was not producing any signal. So I brought it in here, did a real quick alignment of the IF to at least get, signal pass through for debugging purposes, and a quick RF alignment recruit for the same purpose. And that's the complete movement of the signal all the way through and testing will be the subject of the next video. So why were those rectifier tubes, which tested out all right? Well, I don't have a very good tube tester. That's a step one. Can't afford Hickok and some of these fancy ones. I have just the kind of cheap ones they used to have in the stores and so forth. But it gives me an idea, except when it comes to rectifier tubes. So the thing to think about in terms of the high voltage power supply. This tube is receiving a really a 300 volts here, 300 volts here, AC signal to the plates. So these plates are working in opposition to each other because here's the ground in the middle. And the energy transferred to this circuit is pulling electrons from the ground to the plate. Actually, this, and let me recommend also that you go to Mr. Carlson's YouTube channel and see his latest video on what's inside this tube amplifier. There's a lot of insight into how power supplies work. In fact, just a few words out of his mouth switches on a lot of lights. This filament that goes through the rectifier tube is just a 5-volt AC line, which is doing nothing but heating up the filament. What you have here is, because of the high potential of the plates, first this one, this one, this one, this one. Think of it as a diode. It only goes in one direction. From electrons come from the filament to the plate, and they go to the ground. So it's drawing, drawing, drawing off this filament. That results in a positive potential along this line, and then it's filtered and so forth. But it's a positive potential that's continually on this line, and that's what sets up your B plus power supply. The circuit, though, is the ground to the cathode of the various tubes. This provides the electrons, which goes to the plate, which gets its positive, move my hand out of it, gets its positive potential from the B plus line. So the circuit then is from ground to plate, through to here, then to here, and back to ground. And that's how rectifiers work. Well, why do they get tired? This filament emission declines with age. And they can test out fine on these cheap tube testers that I have. But it's still not going to deliver enough potential on this B plus line to function. So I'm thinking that much of my issues in here are related to the tubes, which came out of the original set, which was first that rectifier, then one old one I had, which I knew wasn't very good. Then I finally put in the Russian, and that worked. Hope you have a great weekend this Easter. I feel like we'll be getting out of all this pretty soon. And just remember that the good news that we heard today, and that is that He is risen. This is Hallicrafters Rehabs. Hoping you're having a blessed weekend.